Let's take a look at the process of dividing rational expressions. Dividing by a rational expression is the same as multiplying by its reciprocal. So if I focus on what we're dividing by y minus 2 over 9 is the same as multiplying by 9 over y minus 2, where I take the numerator of the expression and turn that into the denominator of its reciprocal, and the denominator 9 becomes the numerator. So this is the same, the first part of the expression stays exactly the same, but I take the reciprocal of the second part of the expression. So dividing 10y minus 20 over 21y by y minus 2 over 9 is the same as multiplying 10y minus 20 over 21y by the reciprocal of the second part. So the first part of the expression, the first rational expression, stays the same, and the second one, I take its reciprocal, and that allows me to turn division into multiplication. And so now we can use the idea that multiplying, I can multiply the two numerators together. I get 10y minus 20 times 9, and I can multiply the two denominators together. 21y times y minus 2. Now we could multiply this out, but before we do, it's a great idea to check for common factors. So are there any common factors? In order to see that, I want to completely factor the expressions. And this is mostly what we have, except this expression, the 10y minus 20, it will help us if we factor out that common factor of 10. So 10 divides itself, but it also divides 20. So if I factor out a 10, y minus 2 is left behind. So then it becomes pretty obvious that y minus 2 is a common factor. Taking that whole expression, I can't just cancel the y's, I can't just cancel the 2's, but I can cancel that whole expression in the parentheses with the entire expression up top. So we get a simpler expression, 10 times 9 divided by 21y. And before we say that that's the final answer, of course, I could multiply together the 10 and the 9, and that wouldn't be too bad. But 21 and 9 have a common factor. They're both divisible by 3, so that leaves a 3 behind. 3 times 3 is 9, and 3 times 7 is 21. So canceling that 3, and I could write that out maybe to see it a little bit more carefully. This is 10 times 3 times 3 divided by 3 times 7 times y. And so this 3 down here cancels with one of the 3's up top. And our final answer then becomes 30 divided by 7y. I encourage you to pause the video for a moment, try to work on one or both of these problems. In just a moment I'll work through the answers, but I encourage you to pause the video and try it on your own first. Alright, I hope you took a moment to try to find the answer to these division problems. Let's see what we get. So x divided by x over x plus 3 and then divided by this other expression is the same as leaving that first one exactly the same and then multiplying by the reciprocal. So x squared plus 2x minus 15. The bottom of the second expression, the one that we're dividing by, becomes the numerator over x squared plus 5x. Now I can put them together as a single rational expression. I need parentheses around the second part because all three of those terms are multiplied by x. And in the denominator I need parentheses around both the x plus 3 and around x squared plus 5x. Without the parentheses, it really means something very different. So before I kind of think about actually multiplying that out, though, I want to factor. Right? So remember, factor first. because there might be, and for most of the problems that you'll probably see from a textbook or on homework problems, they'll have common factors that'll cancel. They don't have to, but they usually do. So let's see. So this second part of the expression is what I want to focus on. X, of course, is already a factor. I can't do anything with that. But here, x squared plus 2x minus 15, I want to look for a pair of numbers that multiply to equal negative 15 and add to equal 2. X plus 5, because I want the 2 to be positive, and x minus 3 are going to work, right? 15 is 3 times 5. 5 and 3 are 2 numbers apart, and I want a positive 2 in the middle. On the bottom, I have x plus 3, and I can factor out an x, and that leaves behind x plus 5. So x plus 5 is a common factor, and so is the x. So what we're left with is simply x minus 3 up top, and now I can drop the parentheses because there's nothing else that's being multiplied with, over x plus 3. For this other expression, in a similar way, y squared minus 1 over y divided by y plus 1 over y minus 1 is the same as multiplying y squared minus 1 over y by y minus 1 over y plus 1. So I'm taking the reciprocal of that second expression. And so I could write those together as a single expression. To speed things up, while I do that, I could actually think, y squared minus 1, that's going to be y plus 1 times y minus 1. So just that part of the expression factors to equal this. And then the other numerator, y minus 1, belongs up top. And then in the denominator I have y times y plus 1. So the y plus 1 and the y plus 1 are common factors. Taking both of those together, individually they're not. I can't cancel just the y with a y. I can't cancel just the 1 with a 1, but together I can cancel them as common factors. So we're left with y minus 1 times y minus 1 up top, and just a y in the denominator. And I could write that a little bit more simply because that factor is now repeated. Since I have the same thing up top, I can write that as y minus 1 squared over y. I wouldn't have to, but I could write it more simply in that way. I could also, alternatively, I could multiply that out. Or if we multiply that out, it's a perfect squared trinomial. I get y squared minus 2y plus 1 divided by y. But typically the factored expression is kind of nicer to stick with because then it's clear there are no additional common factors. I hope you enjoyed the video. Thanks for watching.